Namaskar, and welcome back to another exciting episode of Pal Talk Statistics. I'm your host, Dr. Chinmoy, here to help you decode the world of numbers step by step.
And I am Ria, your co-host. Today we are discussing a very interesting non-parametric method called Spearman's rank correlation coefficient, also known as Spearman's rho. What is Spearman's rank correlation?
To start with, let's understand what is correlation. In statistics, correlation tells us how strongly two variables are related. Now, when the data is not normally distributed or is ordinal in nature, we use Spearman's rank correlation instead of Pearson's.
Yes, Spearman's rank correlation measures the strength and direction of a monotonic relationship between two ranked variables. It doesn't assume any linearity or normal distribution.
That's right. So whether your data is based on survey rankings, performance scores, or preference orders, Spearman's test is your go-to technique.
Real-life example. Let's make this real. Suppose a teacher ranks students based on their performance in math and science. She wants to see if there's a relationship between how well students do in these two subjects.
She can use Spearman's correlation to check if students who rank high in math also tend to rank high in science. If the result is close to +1, there's a strong positive relationship. If it's near -1, it's a strong negative relationship. So basically, we first rank the two sets of data, calculate the difference in ranks, square those differences, and then plug them into the formula.
And once you compute rho, you interpret the value. Rho is equal to +1, perfect positive monotonic relationship. Rho is equal to -1, perfect negative monotonic relationship. Rho is equal to 0, no correlation. When to use Spearman's rank correlation?
It's very useful when your data is ordinal in nature, like rankings, not normally distributed, has outliers that would distort Pearson's correlation, follows a monotonic but not necessarily linear trend.
So remember, if your variables are increasing or decreasing consistently, even if not at a constant rate, Spearman's is the right choice.
Practical use cases. Here are some popular use cases. Education, comparing student ranks across subjects. Market research, customer preference rankings. Healthcare, ranking severity of symptoms versus dosage level. Social sciences, comparing attitude scores and behavior ratings.
And it's easily done in software too. In SPSS, you go to bivariate correlation and select Spearman. In Python, use scipy.stats.spearman_r. In R, it's call.test bracket x, y, method is equal to Spearman.
Reporting the result. Let's say you got rho is equal to 0.82 with a p-value less than 0.01. Your report would be, there was a strong statistically significant positive correlation between math and science ranks, rho is equal to 0.82, p less than 0.01.
Simple, to the point, and effective. And remember, always check the p-value to test significance, especially in research papers.
Spearman versus Pearson. Now some listeners may be wondering when to use Pearson and when to use Spearman.
Pearson is best for interval or ratio data that's normally distributed and linearly related. Spearman is perfect when the data is ordinal, nonlinear, or skewed.
In short, Spearman is more robust when assumptions of Pearson are violated.
Alright, let's recap. Spearman's rank correlation measures the strength of a monotonic relationship between two variables. It uses ranks instead of raw values. The correlation coefficient rho ranges between -1 and +1. It's a non-parametric test useful for ordinal data and non-normal distributions.
This test plays a critical role in social sciences, education, medicine, and anywhere ranking is involved.
That brings us to the end of today's episode on Spearman's rank correlation. We hope you found it insightful.
If you're enjoying Pal Talk Statistics, don't forget to follow us and share the podcast with your friends, students, and colleagues. Signing off from Pal Talk Statistics, stay curious and keep learning.